let's record going through some of these homeworks, right? Okay. All right, so looking at 45, we started by noticing that this was quadratic and that it was factorable. So I can then set each of these factors equal to 0 and solve them independently. But remember, we're not trying to solve for y, we're trying to solve for x. So I have to substitute back in my tan x's. And hopefully at this point you recognize that I don't really need to solve both of these equations because they're the same equation. Did you guys see that? Yeah, so I'm just going to ignore one of them. So x is going to be the tan inverse of -1. Everybody's okay with that to there? Do I need to slow down? No? Okay. So what do I do then? I go to my unit circle and look for the locations where tangent is equal to -1. When I do that, I know it's going to be in the second and fourth quadrants. So I get that x is 3 pi over 4 and also 7 pi over 4. So that's my answer for part A. Everybody cool with that? Remember that tangent is y over x. So if they have the same, the x and y coordinates on the universal unit circle are the same other than their sign, then I know I'm going to get -1, right? Okay? So that's part A. For part B, we're asking for all the solutions. So what I need is every angle coterminal to these. So again, kind of what we've been standard doing is just tacking on a plus 2k to the end of these. But here you might notice that 3 pi over 4 and 7 pi over 4 are how far apart? They're pi units, right? 3 pi over 4 is over there and 7 pi over 4 is there. So that's pi units that way and then pi units again. So I could combine these together and just write this solution a little bit more simply as one equation, where instead of adding 2 pi k to each of them, I can just pick one of them and add pi k. So that's saying that solution and then every other angle coterminal to it is the plus 2 pi k is saying, okay, 3 pi over 4 is an answer, and then every angle coterminal to that is also an answer.
So if it was like 3 pi over 4 and 14 pi over 4, and then you have like 3 pi over 4 plus 2 pi k, that would be your thing. Okay.
Yeah, you're just always adding 2 pi k.
Okay, and then you can simplify it by finding the difference.
Well, assuming that the difference in both directions is the same, right? If I look at them, look at the graph of where those two solutions are, they're pi distance in both directions. That's the key. If it's not the same distance both ways, you know, like for example, if I had answers here and here, like maybe this is 2/3 pi and this one is 4/3 pi, I can't combine those into one answer. There's nothing to do with that. I just have to leave them as two separates. I can only do the combining when they are, well, not coterminal, but they're like the same distance each direction, if that makes any sense. Does that?
Are they usually going to be the same?
If you're dealing with tangents, I think other than the quadrantal things, they should be.
Okay.
If you're dealing with sines and cosines, never except possibly if they're quadrantal.
Okay.
Do you know what I mean by quadrantal? Okay, by quadrantal I mean that the terminal side of the angle like lies on one of the x or y axes.
Okay.
So in that case, that maybe you have something where you can do that too for sines and cosines. and maybe you don't have something you can do that too for tangents. But otherwise, no for sine and cosine and yes for tangent, I think. I'd have to think a little bit harder about that, but I'm trying to give you an almost always answer there.
Okay.
I haven't thought about it hard enough to know if it's always, but if there's like a weird counterexample or something.
Okay.
Certainly for tangent, you need to be on the lookout for that. Yeah. Okay. All right. Should we do C and D? Okay. All right. So C is negative 2 pi to positive 2 pi. So certainly we have our answers for part A, because our answers from part A were 0 to 2 pi, right? Do you need me to use a different color, Andrew? Is the red bothering you? Is the red bothering you? It looks like you're having trouble. Are you okay? I can do a different color. It's not a big deal. What? Sure. So the other part that we have to worry about then is negative pi to 0, right? That's the other half of our answers in part C that we haven't found yet. How would I find those values? I'm just going to subtract 2 pi from my answers for A. All I do is need to find something coterminal in the other direction. So that's going to give me negative pi over 4, and then negative pi over 4. Yeah, so in the directions, in general, for every problem we're doing, A, B, C, and D are the same range of values for x. So each of them is different, but it's the same for... Exactly. Yep. So in part D, the values that I'm looking for are between negative pi and 4 pi. So I know my answers for part A are in there. Everybody okay with that? And some of my answers for part C are going to be in there, but I have to be a little bit careful. Because here I'm only concerned about things that are between negative pi and 0. So I'm going to go back to my answers for part C and just take the ones that are greater than negative pi. So just negative pi over 4. I don't want negative pi over 4. That one's too small. Negative pi over 4, excuse me. Everybody good with that? So the last set of answers I need are the things between 2 pi and 4 pi. Does that help where I'm showing you like what part of the interval I'm finding the answers in like this?
Yeah, and that's the range that gives you the original question.
Yeah, so that's the range overall. So I'm just looking at sections of it.
Yeah, okay.
So that I can use my previous answers. I can pull from them. Good. Okay. So the last part now, I need to find things between 2 pi and 4 pi. So I don't know what those are yet, but I can find them by just looking at things that are coterminal to my answers for part A. Should I be adding 2 pi or subtracting 2 pi? Adding, because between 2 pi and 4 pi is bigger, right? So that's going to give me 11 pi over 4 and 15 pi over 4. And that's it. Now I'm done.
Okay, so, sorry, can I ask you a question?
Absolutely.
Okay, so for the negative pi over 4,
Mm-hmm.
how did you get that again?
So I took my answer from part A,
Okay.
and I subtracted 2 pi from each of them.
Okay.
So 2 pi is negative 8 pi over 4.
Yeah.
So 3 pi over 4 minus 8 pi over 4 is negative 5 pi over 4. That's the first answer. And then 7 pi over 4 minus 8 pi over 4 is negative 1 pi over 4.
The other one.
And the other one.
Or for now, for B, how did you get the negative pi over 4 right there?
So I need answers between negative pi and 0.
Yeah.
So I went up here and looked at my answers between negative 2 pi and 0.
Okay.
And I'm just going to check them to see if they're inside of negative pi to 0 or if they're too small.
Oh, okay.
So I noticed this one is too small, so I didn't take it. The other one, though, fits, so I did take it. And I'm doing it that way, Bella, just so I don't have to, like, redo anything. Yeah, I'm just using my answer from part C because I've already got my answer.
And then you add, or how did you get the 11 pi over 4 and 13 pi over 4?
So I found something coterminal to my answers from part A.
Okay.
And since they needed to be bigger, because they're in an interval further down, I added 2 pi to each of them.
So you added 2 pi to 3 pi over 4 and 7 pi over 4?
Correct. And when I make a common denominator and all that jazz, I get those answers. Okay? Jackie, are you happy? Okay. Okay. Other students that are having a minor panic attack over this topic, did this feel okay? Better. I'll settle for better. Okay. Yeah, who's next? What? Anna, which one did you want to do? Okay. You want to do something different? That's fine.
No, yeah. Can we do 31 too?
30 was in the last set.
38.
Oh, 38. Sure. So this one, nothing special I need to do. I'm just going to take sine inverse of both sides. And then I'm going to go to the unit circle and find the places where the y-coordinate is 1. There's just one place where that happens, at pi over 2.
So that's your A.
So that's my answer for part A. For part B, this is kind of dummy proof. Since there's only one answer in part A, I can only write one answer in part B. There's obviously nothing to combine it with. So I just slap the 2 pi k on the end and be done. For part C, I need to look at things between negative 2 pi and positive 2 pi. So this answer is between 0 and 2 pi. So obviously that answer is going to be there, right? Everybody agree with that? Okay. The other place I need to look is if there's an answer between negative 2 pi and 0. How would I find that? Yep. So I get that. And that's it. That's the only one. For D, we're looking at negative pi to 4 pi. So I know I have my answers from part A. From part C, I'm going to go and look at my negative answers. So I'm going to look at this one. Is that between negative pi and 0? No, right? It's too small, so I'm not going to use it. So there's nothing there. And then I just need to look at between 2 pi and 4 pi. How would I find that answer? Add 2 pi to that guy. So I get 5 pi over 2. And now I'm done.
And you couldn't get anything in the range from -5 to 0, so that's how you get it.
Right. Yeah, there's no answer that fell inside of there, so I just left it blank. Because I looked over here, and this one was too small. Right? That's negative 1.5 pi.
You look back at the old one.
Yep.
And then you added 2 pi to that pi over 2.
Yep. To get to the other one. Okay. What do you guys think? Okay, good. Which one's next? 38. Okay. All right, so the first thing that I would do is I would divide both sides by cosine squared x over 3. Why would I do that? Because sine squared over cosine squared is tangent squared. Everybody okay there? And then I'm going to square root both sides. Is everybody okay, still with me to here? I think you just need more Mountain Dew in your diet.
How many a day do you have?
I'm trying to get down to like 1 soda a day.
Oh, that's not.
And like this size. So like one of that size a day. Friday just it was not going to be. Friday was hard, so I knew I was not going to do one today. I do not drink coffee. Yeah.
I drink coffee.
I don't like the taste.
My mom tries to take my coffee.
It's too bitter for me.
I like it.
All right, let's continue on. Good to know. I'll check that out. All right. So because of the plus or minus, I'm going to split this into 2 pieces. Okay. So, Alicia, I don't have a way to cancel out the sine and cosine when they're on the opposite sides like that. So what I did is I combined them together into a tangent, because sine over cosine is tangent. So I started by dividing both sides by cosine squared x over 3. Is that okay there? And that's a trick that we've used multiple times in this homework assignment. It's a good one to remember, is that you can turn something into a tangent that way. Okay. So what I'm going to need then is x over 3 is the tangent inverse of square root 3, and x over 3 is equal to the tangent inverse of negative square root 3. Everybody's okay so far to here? Now remember, I'm going to do part B first for this kind of a problem. Why this? What about this kind of a problem tells me I should do part B first? Yeah, I have a coefficient attached to my x. Okay? So I'm going to do part B first. Just keep that in mind. So, what values am I looking for? I'm looking for a place where the y-coordinate has a square root of 3 in it, because tangent is y over x. So that happens here at pi over 3. And also at the y-coordinate is that one, 4 pi over 3. And we'll do the same thing over here. So that's going to be 2 pi over 3. And also 5 pi over 3.
Okay, how did you use
So I did the same thing I would do for A, but I'm just putting the 2 pi k's at the end. Okay. And the reason I need to do this is because my answers for A, I don't know how many I'm necessarily going to have and where they're going to be at. I need my answer for B to find my answers for A, because there's a horizontal stretch or shrink going on to this function. In this case, it's a stretch, because it's the B value is, yeah. Okay, so to solve for x, then I multiply both sides by 3, right? Notice when I do that, I have to distribute the 3 to both places. So I got pi plus 6 pi. So that's my answer there for B. Okay with that? No? Where did I lose you at?
but it's okay, I'll get it.
Famous last words. Okay. All right. So what I'm going to do is I'm going to pick some values for K. And see what my answers or what I'm going to get. So I've just picked some values for K. And I'm going to plug them in. What are we confused by? Okay. So K, remember when we write, stop, listen, everybody listen, okay? When we write our infinite solutions, we have plus 6 pi k at the end. K is an integer, right? So I'm picking some integer values for k. I chose these ones because the range of values in my answers for A, C, and D are all relatively close to 0, right? Our answers for A have typically been when k is 0 in the infinite solutions before, right? Because we just want the values from the unit circle, right? So I just picked some values surrounding that. Here, let me go back and just kind of illustrate what's going on, okay? So let's look at the previous problem. If I look at the infinite solution, if I pick k to be 0, what do I get? Pi over 2. That's my answer for A. If I pick k to be negative 1, what do I get? I get negative 3 pi over 2. That's the other part for my answer for C. If I pick k to be 1, what do I get? 5 pi over 2. That's the other part for my answer for D. So that's all I'm doing down there, is I just using that same pattern. Now, because there's a transformation going on, I might need less than k equals 0, negative 1, and 1. I might not need all of the answers for all of those values. I might not even need any of some of those. That's okay. Or I might need more than k equals 1, 0, and negative 1. But we'll find out, right?
So is that why you found all of those like coterminal?
Yes, they would all be coterminal.
Okay. And then where did you get in those equations that you have x equals like pi and 4 pi and 2 pi and 5 pi, like
Yeah.
plus or 5k? Where did you get pi, 4 pi, 2 pi, and 5 pi?
So I solved this equation for x. So I multiplied both sides by 3.
Yes.
So 3 times pi over 3 is pi.
Yes.
And 3 times 2 pi k is 6 pi k.
Okay.
That's all.
And then you did before by the other.
So then I did the same thing for the other 3.
Oh.
Okay? Okay, good. All right. So for part A, we want our answers there, right? So look at the list that I've just generated above. How many answers do you see that fit in that range? Just one. The only answer is this one. Why isn't pi over 2 work?
Oh, because it doesn't have a bracket.
Because it doesn't have a bracket. Very good. Okay, so let's go to our list here. And which ones fit? Those 4, right? Is that okay with everybody? You see how I'm using now you see why I generated those values, or why I use those values, right? Okay. And then we still need to do D, right? Okay, so what values do we see here? Negative pi, pi, 2 pi, but not 4 pi because it has not a bracket. So that's it. So what did we not end up needing? We didn't need k equals 1. That's fine. If I did a little bit of extra, it was no problem generating those answers. It was easy to do that. Notice that even from those lists, I didn't even end up using all of the values from either of those lists, right? In fact, the only ones that ended up, well, I shouldn't say that. I guess they all ended up mattering a little bit. Okay with that? So, again, the setup, getting that first initial set of infinite answers was a little bit of work, right? But once we got that, doing A, B, and C, or A, C, and D was pretty easy, right? We just generated a list of answers and pulled from the list what fit. Should we do another? Great. Let's do another. Which one should we look at next? $41. Okay. Can we do one where the coefficient is greater than 1? Like maybe 36 or 39 or 35 or 36? Okay. So, just as a heads up here, a useful fact. Is everyone listening to the useful fact? So, the coefficient on our x will also help me predict the number of solutions I should be looking for. So on 38, the coefficient is 1/3. I'd expect 1/3 of the solutions that I would have if x was, or if the coefficient was 1. So if the coefficient was 1, I would have gotten 3 solutions here instead of just 1. Down here, how many solutions should I be looking for? Twice as many as usual, because the coefficient is 2. Okay? All right. So let's start. Yep. And then divide by 6 to get 1/2. So 2x is the sine inverse of 1/2. I'm going to go to my unit circle and find the places where the y-coordinate is 1/2. Okay with that? And then I'll divide both sides by 2, or really I'm going to think about multiplying by 1/2 because I have fractions. It just makes it a little easier to think about it that way. That's my answer for B. Okay? All right. So, when k equals 0, I get pi over 12 and 5 pi over 12, right? Both of those would be answers in A. Everybody agree with that? Okay. When k equals 1, I'll add pi to each of these. So that's going to be 13 pi over 12 and 17 pi over 12. Both of those would still be answers, right? Everybody agree with that? Both of those are less than 2 pi. You guys agree with that? Okay. Let's check for k equals 2. So I'll add pi to each of those answers. And those are both too big. So I have my answers now all for A. Everybody go to that? Is everybody okay with how we got our answers for A? So I just kept picking values for K until I found stuff that didn't work. Now, I know all of those answers for A are going to be answers in C, right? What I care about, though, are the negative ones. So maybe I'll pick K to be -1 now. So now I'll subtract pi from each of these ones up at K equals 0. So that's going to be -11 pi over 12. And then -7 pi over 12. Both of those are between -2 pi and +2 pi, right? Maybe I can subtract another pi. Both of those are also between -2 pi and +2 pi. But if I subtract pi again, I can tell I'm going to be too small, right? So now I'm just going to go ahead and take those onto my list. And I don't feel like writing down my answers for part A, so I'm just going to write A. Raul. Of course. All right. For D, I need these two answers, right? Everybody agree with that? Those are the only ones that are bigger than -pi of my negative answers from part C. Everybody agree with that? 11. Okay. I have all my answers from part A. And then I have to worry about the part from from 2 pi to 4 pi. So we know that these two are going to be there, right? We haven't used those two yet. Those are both bigger than 2 pi. And then we should also check K equals 3. See if those are too big yet. Those are both okay. Those are less than 4 pi. But if I try K equals 4, that one's too big, and the other one will definitely be too big, as it's bigger than that one would be. So we're done. Okay. So on your assignment, would you necessarily have to write down all these things? No. I'm writing these things down so you can see where I'm getting these numbers from. I am only writing those down so you can see what the numbers, where these numbers are coming from. You could do this all like, you're just taking the infinite solution and you're just, the infinite solution, and you're basically just adding pi, and as long as you keep getting values in your range, you just keep adding until it stops getting something in the range, and you stop. And you go to the next one. You just keep adding pi, right? I just needed to do it in a way that, like, you guys can see what it is that I'm doing. So I tried to do it in a way that was, like, visual, since you're taking notes on it, that it would be useful looking back at, or it's not just like, oh, he did a bunch of hand-wavy magic and he gets some answers. And I look at my paper and there's no work written down for it. Right? If we're taking notes on it, it doesn't make a lot of sense to show you, like, a way to do it without writing anything down. I'm going to write a bunch of stuff down so you can go back and go, oh, that's where he got the answers from. You know what I mean? Okay. So again, like, the way that I'm showing you to do it by hand is not necessarily like you have to do all of this. You could do, like generating all these values that we might or might not be using. You could just not write those all down there. You could just write them on the list where they go. Okay with that? All right. I'm stopping here because I do have a little bit more to talk about in section 5.2. So let's say we want to solve this monster. Okay. So to solve something like this, my first step is, nope, I'm not going to cry. No. I'm going to think about this. Stop talking, please. Stop talking, please. I'm going to think about this the same way I would solving like a polynomial. I don't want to do that because we're looking for solutions of x, and tangent very likely could be 0, and I don't want to divide by 0. What I'm going to do is I'm going to move everything onto one side. And then I'm going to factor off a tan 2x. Everybody okay there? Okay. So now I can use the zero product property and set tan 2x equal to 0. And sine squared 1/2 x minus 1 equal to 0. Raul? That has a factor of tan 2x on it, right? So imagine this says x y squared minus x is equal to 0. If I factor the x off, I'd have y squared minus 1 is equal to 0, right? That's just exactly what we did there, except we have tan 2x and sine of 1/2 x instead of y, right? But it's kind of the same thing. Okay? All right? So I'm going to say 2x is equal to tan inverse of 0, and 1/2 x is equal to sine inverse of 1, and also 1/2 x is equal to sine inverse of -1. Yeah, I added the 1 over and square rooted, and then took the sine inverse after I broke it into two equations. So I did a bunch of algebra there that I skipped writing down, in the interest of time. I did skip some things. You caught me. Okay? So now I'm going to go to the unit circle and look for the places where tangent is 0. Tangent is 0 where the y-coordinate is 0 because it's y over x. So that happens at 0 and at pi. You could write 2 pi again, but that's the same thing as 0. Okay, remember we talked about this at the very beginning here, that when we do the inverses here, we're not actually doing the inverse like on our calculator, because what we're trying to do is solve for x, and there's lots of x's here. There's not just the output from the calculator. Does that make sense, Joanna? Okay, so we're kind of ignoring the range for those functions. So, good point. Now, we'll divide both sides by 2. So we end up with x equals 0 plus pi k, and x equals pi over 2 plus pi k. And then similarly over here, I have, looking for the place where the y-coordinate is 1. That happens only at pi over 2. And then when I multiply both sides by 2, I get pi plus 4k. And similarly here, look for where the y-coordinate is -1. That happens only at 3 pi over 2. And when I multiply both sides by 2, I get 3 pi plus 2 pi k. I'm sorry, 4 pi k. Okay. So the answers I'm looking for are between 0 and 2 pi. So looking at this solution, if k equals 0, I just get 0, right? So that works. If k equals 1, I get pi. That works. If k equals 2, I get 2 pi. That's not in my range, so I'm done with that one. Everybody's okay there? Okay. Let's move on to this one. If k equals 0, I get pi over 2. That's in the range. If k equals 1, I get 3 pi over 2. That's in the range. If k equals 2, I get 5 pi over 2, and that's too big. Everybody so far so good? All right, I'm going to go to this one now. If k equals 0, I get pi. I've already written pi down. I'm not going to write it again. If k equals 1, I get 5 pi. That's too big. I'm done. Well, it's just a duplicate of one I've already written down, so I'm not going to write it again. I'll move on to the next one. If k equals 0, I get 3 pi. That's too big. I'm done. So this is it. That's my answers. So I guess like, there you go. And this last one contributed nothing to my solutions. Everything was too big. Hi, Kev. Ah, cool. What do you think? It was okay. Wasn't that bad, right? Let's do another then. We only have 6 minutes. Good to know. Okay, let's do this one. What should we do first here? Yeah, let's subtract that tangent to the other side. I'm just picking that for these examples because it's just kind of convenient. But no, the ranges could be kooky. Yeah, do you want to do something kooky here? I just didn't want to make it too complicated right away. You want to be kooky? Okay, let's do that then. All right. Then we can factor a tangent out. And then we can set each of these factors equal to 0. So x is equal to the tan inverse of 0, and and x is equal to sine inverse of 1/2. So x is 0 at where the y is 0, which happens at these two places. And sine is 1/2 when the y coordinate is 1/2. At these two places. So we're good there. Okay. So let's look at the first equation. When k equals 0, oh, that should be negative. Did I make that negative up here? No, let's just do positive. That's going to be 2. All right. So when k equals 0, I get 0. That's too small. When k equals 1, I get 2 pi. That works. When k equals 2, I get 4 pi. That works. When k equals 3, I get 6 pi, and that's too big. So I'm done with the first one. Moving on to the next one. When k equals 0, I get pi. That's too small. When k equals 1, I get 3 pi. That works. When k equals 2, I get 5 pi. That works. When k equals 3, I get 7 pi, and that's too big. Moving on to the next one. When k equals 0, I get pi over 6. That's too small. When k equals 1, I get 13 pi over 6. That works. And then I get 25 pi over 6. That works. And then I go to 37 pi over 6. And that's too big. And then the last one we'll look at is this one. When k equals 0, I get 5 pi over 6. That's too small. When k equals 1, I get 17 pi over 6. That one works. When k equals 3, I get 29 pi over 6. That works. And when k equals when k equals 3, excuse me, I'm not at 4 yet, I get 41 pi over 6, and that's too big. So those are my answers. Notice here I've stopped writing down all the values for k, right, and all the outputs. I've just done it one solution by at a time. Okay. We'll stop here.